Bismillahirrahmanirrahim. Assalamualaikum dan selamat pagi. Bertemu kembali kita di saluran YouTube College Meritokrasi Kejuruteraan Kedah untuk pembelajaran kuliah secara maya atau secara online dipancarkan secara langsung melalui saluran YouTube. Okey, pembelajaran kuliah secara maya ini dijalankan setiap hari Ahad, Isnin, Selasa, Rabu dan Khamis jam 10 pagi. Okey, diharap para pelajar semua bersemangat dan teruja untuk belajar kuliah online kita hari ini. Okey. Okay, actually last week we have done our first chapter is integration. For today, I will continue with the new chapter is chapter 2. Okay, the chapter is first order differential equation. Okay. For your information, okay, topic first order differential equation, we have 3 subtopic here, okay. 2.1 is separable variable, 2.2 first order linear differential equation, and 2.3 is application. Okay, for subtopic 2.1, okay, separable variable, okay, our course learning outcome at the end of this topic, students should be able to distinguish between general and particular solution, B, solve separable differential equation. Okay, for first lecture today, we cover subtopic 2.1 only is separable variable. Okay, for your information, okay, let's say we have introduction. Okay, consider the following equation. Okay, given that if we have a equation y equal to 2x squared plus 4x minus 3, and then we differentiate, we can get dy over dx equal 4x plus 4. Okay, if we reverse the process, okay, actually we can get a differential equation dy. If we have a equation dy over dx equal 4x plus 4, and then we can solve the equation by integration to get the solution back. Okay, the equation is y equal to 2x squared plus 4x minus 3. Okay, roughly we know that, okay, from equation y to x squared plus 4x minus 3, we differentiate, we can get dy over dx equal to 4x plus 4. When we integrate dy over dx equal to 4x plus 4, actually we can get back, okay, the equation y equal to 2x squared plus 4x minus 3. The process is integration. Okay. I hope you will understand a little bit more about differential equation. Okay, dy over dx equal to 4x plus 4 is a differential equation. Okay, we have definition for DE. Okay, a differential equation or short form is DE is one which relate an independent or dependent variable with one or more derivative. Okay, with one or more derivative. Okay, for independent, we refer to variable y, and dependent, we refer to variable x. And derivative here, we know that derivative is dy over dx, d square y over dx square, dx cube over dy cube. Okay, d cube y, over dx cube. Okay, another example for derivative. Okay, let we look example equation 1 here. We have 3 d square y over dx square plus 4 dy over dx minus 7 equal to 0. Okay, we know that, okay, we have one derivative here, d square y over dx square And then another one is dy over dx. Okay. For example number 2, we have here is dy over dx to the power of 2 plus y squared equals sine x. Okay, the derivative is dy over dx. That's example for the differential equation. Okay, we also have a definition for order and degree. Okay, order. What is order? Order is the highest derivative in a differential equation. Okay, highlight the highest derivative. Okay, while the degree is the highest power of the highest derivative which occur in a differential equation. Okay, that's the term for order and degree. Okay, to more understanding about order and degree, let me fill up the table to know that, okay, to understand the concept order and degree. Okay, for example here class, we have differential equation number 1 is y to the power of 5 dy over dx equal x square plus 5. Okay, we know that we only have one derivative here, dy over dx. Okay, that means the order is 1. Okay, the answer is 1. Okay, the order is 1, okay, because of the first derivative. Okay, what is the degree? We refer the dy over dx. We know that, okay, the power of dy over dx is 1. Okay, to the power of 1, that means the degree, okay, also 1 as the answer. Okay, that's for DE equation number 1. Okay, next for number 2, we have here is 7 d square y over dx square equal dy over dx minus 3. Okay, from this question, we know we have two derivative here. Okay, first is second derivative, another one is first derivative. Okay, that means the answer for order is 2 because second derivative, okay, d square y over dx square. And then for degree, okay, we know that, okay, the power of degree, d square y over dx square is to the power of 1. Okay, the answer for degree also is 1. Okay, for equation number 3, we have here is dy over dx to the power of 6 equal d cube y over dx cube to the power of 4 plus 1. Okay, we also have two derivative here. Okay, first is dy over dx. Okay, second one is d cube y over dx cube. Okay, that means the answer for order is 3 because of the third derivative. And then we refer to the third derivative, we know that the power is 4. That means the degree is 4. Okay. And then for equation DE equation number 3, we have only one DE, dy over dx. Sorry, number 4, yeah. dy over dx. Okay, we know that the order is 1. Okay, the degree is 3. Okay, the order is 1 and the answer for degree is 3. Okay, for DE equation number 5, okay, we have y double prime to the power of 4 plus 2 times y prime to the power of 7 minus 5y equal to 3. Okay, we have two derivatives. Okay, y double prime is meaning for d square y over dx square. Y prime is dy over dx. Okay, this means the order is 2 because of the second derivative, and then the degree is 4. Okay, for DE number 6, okay, differential equation number 6, okay, we have dy over dx to the power of 5 minus 2x equal to 3 sine x minus sine y. Okay, only one derivative here. Okay, that means the order is 1 because of the first derivative, and then the first derivative is to the power of 5. Okay, the degree is 5. Okay, that's a meaning or concept for order and degree for differential equation. Okay, we have a good news here. Okay, in this chapter, we only deal with first order, first degree differential equation. This means our syllabus just cover for first order and first degree differential equation only. Okay, we have two solution here. Okay, general solution and particular solution. Okay, what is general solution? The general solution of a differential equation contain an arbitrary constant C. Okay, and then for particular for example, here we have y equal to 3x cubed plus C. Okay, the C is a constant C. Okay, for particular solution, the particular solution of a differential equation contain a specific initial value and containing no constant C. Okay, for example, we have here is y equal 3x to the power of 3 plus 2. Okay, to find particular solution, the question must given the condition. Okay, what is condition? The condition is the value for x and the value for y. Okay, when we get the value for x and the value for y, we substitute into general solution. We can get the value for c, and then we substitute back at general solution the value for c, and then we can get the particular solution. That's for general solution and particular solution. Okay, to more understanding about particular and general solution, let me have a sample here. Okay, we have a differential equation dy over dx equal to 2x. Okay, we know that the corresponding solution is y equal to x squared plus c by using any method to get y equal to x squared plus c. Okay, that's why this one we assume as a general solution. And then when the question are given y1 equal to 3, that means x equal to 1 and y equal to 3. Then we substitute the value x and value y into general solution. That's why we can get the value 2. Okay, c equal to 2. By substitute the value x equal to 1 and y equal to 3. And then we substitute back, okay, the value for c into general solution. Okay, we substitute at this place. We can get y equal to x squared plus 2. Okay, this is we call as a particular solution. Okay, to more understanding, okay, to find particular solution, we must have a condition value. Okay, to find the value of constant. Okay, we know that, have two methods to solve a differential equation. Okay, first one is separable variable and another one is by integrating factor. But for learning outcome today, we only discuss about separable variable only. Okay, how to solve a DE equation with separable variables? Okay, for example, if differential equation in which the variable can be algebraically separated, okay, that means we can separate the function of x and the function of y. We can solve by using separable variable. Okay, maybe the equation form like, okay, dy over dx equal to function px multiple with function py, or dy over dx equal to function px divided by function qy, or function dy over dx equal to function qy divided by function px. Or roughly, we know that we can separate, okay, the function px and the function py as correctly. We can solve by using separable variables method to solve differential equation. Okay, we have another step to solve by using separable variable. Okay, just I note here is step 1. Okay, we try separate the variable x and y. Okay, that means we separate the function of f and the function of fx and the function of qy. Okay, always, okay, x by the side of dx and y by the side of dy. For your information, we always let, okay, x or function fx on the right side and then function y on the left side. Okay, for example we have dy over dx equal to function px over function py. That means we need to multiple with function qy both side. Okay, multiple with function qy both side and then multiple with dx both side. Okay, that's why we can get function qy dy equal function px dx. Okay, function qy on the left side and then function px on the right side. Okay, and then after that we go to the step 2. We integrate both sides independently. Okay, we integrate function qy dy equal integrate function px dx. Okay, that means we need to integrate respect to y on the left side and then respect to x on the right side. After integrate, actually we get the general solution first. That means we need to, or compulsory, we must put plus c after integration. And then when the question are given condition, we can find particular solution. If the question are not given the condition, we just find general solution only. Okay, to more understand about separable variable method, okay, we do some example here to more understanding about separable variable. Okay, example 1. Okay, the question is solve the differential equation below. Okay, dy over dx equal x over y plus 1. Okay, for solution, we know that, okay, we can separate, okay, the function fx and the function qy, or the function px and the function qy. Okay, how to separate? First, we need to multiply with y plus 1 both sides. Okay, and the second one, we multiply with dx both sides. That's why we can get, okay, y plus 1 dy equal x dx. Okay, y plus 1 dy equal x dx. We assume that this is step 1. Okay, for step 2, after split the variable x and y, we need to integrate both sides. This means write down the integration sign for both sides. Integrate y plus 1 dy equal to integrate x dx. Okay, this is for step 2. Okay, we need to see by using integration. Okay, how to integrate y plus 1? Okay, we know that, okay, we just only use a basic to integrate y plus 1. Okay, integrate y. Okay, integrate y. We can get y squared over 2. Okay, plus integrate 1 is y. Okay, because we are respect to y on the left side. Equal integrate x dx. Okay, integrate x dx is x squared over 2 plus c. Don't forget to write down plus c. Okay, plus c. Okay, this one we can call a general solution. Okay, to find general solution, okay, at least we need to simplify a simple y, okay, or express y in terms of x. Okay, but for this equation, we just have a final answer is y squared over 2 plus y equal to x squared over 2 plus c as a general solution. Okay, so simple for example 1. Okay, next we go to example 2. Okay, the question is solve the differential equation below. The DE equation is dy over dx equal cos x cos square y. Okay, don't be confused. Okay, we have cos x and cos square y, a different variable. Okay, for solution, we know that we can separate the equation or the function px and the function qy. Okay, how to separate? Okay, we need to divide by cos y both sides. Okay, and then multiple with dx both sides. That's why we can get 1 over cos square y dy equal cos x dx. Okay, 1 over cos square y dy equal cos x dx. Okay, let's use step 1. Okay, and then we need to integrate both sides. Okay, that's why we put integration sign is integrate 1 over cos square y dy equal to integrate cos x dx. Okay, before we do integration, make sure we know how to integrate. Okay, we cannot integrate 1 over cos square y. Okay, we need to use a formula, okay, to change it. Okay, 1 over cos y is actually secant square y dy. Okay, secant square y dy equal to integrate cos x dx. Okay, and then we can integrate, okay, for the left and for the right side. Okay, integrate secant square y dy. We can get here is tangent y, and then integrate cos x is sin x. Okay, be careful class. Okay, sometimes we confuse with the sign. Okay, integrate cos is positive sign, differentiate cos is negative sign. Okay, plus c. Okay, that's for final answer for general solution. Tangent y equals sin x plus c. Okay. Next, for example 3, okay, solve the differential equation x for x squared plus 1 minus y exponent to the power y dy over dx equal to 0. Okay, we have a long equation here. Okay, we try to separable. Okay, okay, we copy back the DE equation. Okay, we try to bring first term into the right side. Okay, that's why we can get negative y exponent to the power of y dy over dx equal negative x set for x squared plus 1. Okay, and then don't forget to bring dx, or that means we need to multiple dx both sides. The concept is multiple dx both sides. Okay, we can get y exponent y dy equal x for x squared plus 1 dx. Okay, we know that we have separate, okay, the function of qy and the function of fx. Okay, we have settled for step 1. Okay, next we need to integrate both sides. Okay, the equation become integrate y exponent to the power of y dy equal integrate x for x squared plus 1 dx. Okay, when we look at the right side and left side, we know that, okay, we cannot integrate directly for this left side and right side. Okay, for step 2. Okay, for left side, okay, we must use integration by part, okay, to solve it, okay, to integrate. That means we need to find u equal to y as a polynomial y, okay. We must use a concept of Lopez, okay, to solve by part. Okay, u equal to y, and then we differentiate, we can get du equal to dy. Okay, integrate dv equal to integrate exponent y dy. Integrate dv is v equal exponent y. Okay, that's the information for by part. And then we know that also right side, we must use another method to solve it. Okay, but this one we need to use substitution to integrate right side. Okay, for u substitution, let u equal x squared plus 1. Okay, and then we differentiate. We can get du equal to 2x dx. And then we divide the equation by 2. We can get du over 2 equal x dx. Okay, we not integrate yet. Okay. Okay, for the left side, okay, we must use the formula by part. Okay, uv minus integration v du. Okay, uv minus integration v du. Okay, fill up okay into formula. We can get y exponent to the power of y minus integration exponent y dy equal. Okay, for right side we must use substitute. Okay, that's why we can get integrate u to the power of 1 over 2 multiple with du over 2. Okay, that's mean we need to settle this part for integration and right side for integration. Okay. When we integrate, okay, we can get y exponent to the power of y minus exponent to the power of y equal 1 over 2 u to the power of 3 over 2 divided by 3 over 2 plus c. Okay. For the right side, we need to integrate in term of u, okay, because of the method u substitution. And then, okay, we try to factorize for the left side. Okay, we have exponent to the power of y multiple with y minus 1 equal, we simplify the constant 1 over 2 times 2 over 3, we can get 1 over 3 multiple with x squared plus 1 to the power of 3 over 2 plus c. Okay, this is a final answer as a general solution only because the question are not given the condition to find particular solution. That's why we just stop until general solution only. Okay, we have done 3 example here. Okay, example 1, example 2, and example 3. I hope you more understanding about this chapter is for differential equation when we have settled 3 example here. Okay, we have another 2 example. Okay, next we go to the example 4. Okay, solve the differential equation dy over dx equal x multiple with y minus 2 when y0 equal to 5. Okay, we have something here. Okay, this one we call a condition. Okay, first, okay, we try to separate, okay, the function px and the function py by multiplying, by divide y minus 2 both side. Okay, we divide y minus 2 both side and we multiply with dx both side. That's why we can get 1 over y minus 2 dy equal x dx. Okay, we settle dah step 1. Okay, next we need to integrate both sides. Integrate 1 over y minus 2 dy equal integrate x dx. Okay. For the right side, we need to respect to y and for right side we need to respect x, and then for the left side we need to respect y. Okay. How to integrate 1 over y minus 2? Okay, integrate 1 over y minus 2. Okay, we can get ln y, ln absolute y minus 2. Okay, make sure don't forget, actually we have divide by 1. Okay, here equal integrate x dx actually is x squared to the power of 2 plus c. Okay, that's for general solution. But this question, we have a condition value. We need to substitute the condition value to find the particular solution. Okay. Condition y0 equal to 5 is meaning that y equal to 5 and x equal to 0. Okay, we substitute into general solution when y equal to 5 and x equal to 0. Okay, we can get C here is equal ln 3. Okay, we get C equal ln 3. Okay, we need to substitute the value for C into general solution. Okay, that's why the equation is ln absolute y minus 2 equal x squared over 2 plus ln 3. Okay, we bring ln 3 into the left side. Okay, because of the same properties here, properties ln. Okay, ln absolute y minus 2 minus ln 3 equal to x squared over 2. Okay, we use the properties ln. We can get ln absolute y minus 2 over 3 equal x squared over 2. Okay, and then we exponent both side. Okay, for the equation, we exponent both side to cancel out the ln. Okay, that's why we can get y minus 2 over 3 equal exponent to the power of x squared over 2. And then we try to express y in terms of x. We can get here is y equal 3 exponent to the power x squared over 2 plus 2. Okay, this is a particular solution. Okay. Okay, without C anymore. Okay, next we go to example 5 here. Okay, solve dy over dx equal 3x over y square, and then y0 equal to 1. Okay, this question also have a condition. Okay, y0 equal to 1. Okay, we know that the solution, okay, First, okay, we need to spread, okay, the function px and the function qy. Okay, we can get here y squared dy equal 3x dx. Okay, y squared dy equal to 3x dx. Okay, this step 1. Okay, and then we integrate both sides. We can get integrate y squared dy equal to integrate 3x dx. Okay, this is a for step 2. Okay, to integrate y square, we can get y to the power of 3 over 3 equal, for integrate 3x, we can get 3x square over 2 plus c. Okay, don't forget write down the plus c. Okay, because of the general solution. Okay, we can simplify. Okay, this general solution. Okay, we have here is y to the power of 3 equal 9x square over 2 plus 3c, or y to the power of 3 equal 9x square over 2 plus c. Okay, why? Because we let c equal 3c. Okay, when we let, it's more easy to find out the value for c. This one is a general solution. Okay, we have condition here. Okay, what is the condition? Condition is when x equal to 0, y equal to 1. Okay, we substitute into equation. Okay, I substitute into this equation. Okay. Okay, and then we can get c equal to 1. Okay. When x equal to 0, y equal to 1, we can get c equal to 1. And then we substitute back, okay, y cube equal 9x square over 2 plus 1. Okay, we replace that. The value for c is equal to 1 here. Okay, actually we can simplify the y, the equation y, or express the equation y. We can get here is y equal to cube root 4 9x squared over 2 plus 1. Okay. This is for a particular solution. Okay, we have 2 example for particular solution and 3 example for general solution. Okay, we need to understand the question. Okay, whether the question need to until particular or only general solution. Okay, if the question given condition, okay, we need to find until particular solution to solve differential equation. Okay, that's all for today. Okay, on Tuesday, we will discuss on subtopic 2.2 is integrating factor. Okay, one more thing, don't forget to fill up the link, okay, to fill up the attendance for this lecture online. Okay, thank you again.